Okay, I have told you about this, the first exercise where we have the first order differential equation, and we are basically dealing with the n-splittable cases over here. Obviously, this is much different from your A-level mathematics differential equations, okay? So this was the first case where you were looking for the, what do we call that, integral factor was found in this first exercise. That was your exercise 24A thing over here, okay? And in your second phase, when we had the homogeneous differential equations, so we had the auxiliary equation, but we started through this, okay? And then we had the auxiliary equation, and finding these values of lambda could give us complementary uh, the complementary factor of this general solution of the differential equation, okay? And in the third case, when we moved into, this was your 24b, and then for the 24c case, we didn't have this equal to zero scenario over here, okay? And then we had to go for two times we had to suppose this y. First, for the left hand side, for the complementary factor, we had this y is equal to a to the power lambda x, and for the particular integral, that was, for the right hand side, where we had to suppose accordingly, depending on this, on the form of, on the nature of the right hand side of our differential equation, okay? Now we're going to deal with the cases where, which are none of these cases over here, okay? And to handle these, to solve these differential equations, we have to use some substitutions over here, okay? So we're going to do the first example over here, where we have dy by dx, that is x plus y over x, okay? So to handle this situation, what we are going to do over here is, we're going to suppose that, first, I'll be simplifying this. This is going to be dy by dx, that is equal to 1 plus y over x, okay? So we shall say, okay, let this y over x is equal to u, okay? By the way, these substitutions will be given to us, okay? So there's no need to worry about that. How do we know that? What do we have to substitute in our, to solve our the given differential equation, okay? Anyhow, look at this method. Um, you will see that how this equation, this differential equation, that we clearly right now, since this is the first order differential equation, and we can't write it in the form kg, this is dy by dx plus fy, that is equal to g. So this is clearly, we can't write this in that form, okay? So to handle this, we are going to go for a substitution, that is going to be y over x, that is equal to u. Okay, this gives you y is equal to ux. There is very interesting kind of algebra going to be used here, okay? So we shall find dy by dx. So this is u plus x du by dx, okay? We have this dy by dx. If you put this y over x as u over here, so you see that you can get this dy by dx, that is equal to 1 plus u. So this is one relation, and this is the second relation over here, okay? So you get this 1 plus u, that is equal to u plus du by dx, okay? So these u's are cancelled. So you have du by dx, that is equal to, sorry, there is x with this. I forgot to write this, x du by dx, okay? And that is going to be equal to 1. And then I can write it as this du is equal to dx by x, okay? Now I integrate both the sides. So I have u is equal to ln x plus c, okay? Now I put this u back in as y over x. So you see, you are going to get the required solution here. So this is going to be putting this u back as this y over x. So here is the general solution of this equation. This is going to be y is equal to x ln x plus cx. That is the general solution of this given equation. Please ask if there is any question.
Sir, so basically first we differentiated y is equal to ux,
Yeah,
and then
the
we
given
equated that
uh,
equation
with the
with
given
our first equation, right?
exactly. And when you do that, so you have clearly a new differential equation in terms of x and u, which is a separable or a splitable situation. Okay, and we solve that, and we get to the general solution of the given differential equation. So you see that this equation that we had right in the beginning of this, the question, this is like if we just stick to x and y over here, we can split this and we can find that uh, integral factor over here through which we could solve this first order differential equation. Okay. Now, when you go further into this substitution method, you will be getting very, very like scary kind of equations there, but you don't need to worry. The thing is, you just stick to the basics of the scales, the method that you have learned, inshallah, will be able to get to that. Okay. Now look at this example over here. It says use a suitable substitution. Now, where it is like there are the cases when you can like bring in y over x into your equation. So you will always be putting that y over x equal to u. Okay. So that is why it's not giving you the substitution over here. But nevertheless, this will always be given if you look at all your past paper questions. So this is given there, that what do you have to substitute there. Okay, now moving on to the this example over here, let's try solving this. Okay, so we have here this uh, this is CNN International. Okay, dy by dx. Oh, my t is here. Okay, I will give you the first step, guys, and then you will complete. In the meanwhile, I'll take care of my cup of tea. Okay, but so what you can do over here is you can divide both the sides of this fraction by y. Okay, so if you do that, you will get dy by dx, that is 1 minus y over x over 1 plus y over x. Okay, and then you will say, okay, let this y over x is going to be u, and then this is going to, the party starts from here. Then this is 1 minus u over 1 plus u. Okay, you try this and then I come back. Okay, you must
Sir
be,
Intezar,
yes beta, yes, yes. Mhm.
Sir Intezar, I feel like my answer is wrong. Uh,
No problem, no problem,
I'm
no problem. Let me try this. Let's see how I go about this. Okay. So you have y is equal to ux. Okay. So you have to find du by dx from here. So let's find that du by dx is going to be, first of all, u and then x du by dx. Okay. So, sorry, this is dy by dx. I'm writing du by, this is dy by dx. Okay. So we have this dy by dx over here. So I'm going to equate both of them. So we have 1 minus u over 1 plus u, that is u plus x du by d. Okay. So this is looking to be a very khofnak thing. So don't worry about that. Just keep on going. Okay. So we have x du by dx, that is 1 minus u over 1 plus u minus u. Okay, this color is not very clear, so let me choose this one maybe. How does the pen go on it? Okay, better. Okay, so this is your x du. I have to write a bit small here. So your LCM is 1 plus u. This is 1 minus u minus, now this u into 1 is u and u into u is, so take care of this minus over here. Okay, So this x du by dx is going to be 1 minus 2u minus u square over 1 plus u. Okay, let me erase this thing from here. Okay, and yes. Okay, I need this? No, I think we don't need this. Okay. Okay. So um, okay, just 1 minute. Okay. So now this is, so we have reached up to this. Okay. So this is going to be, now be very careful, very bumpy, very hilly area over here. Okay. So this will be 1 plus u over 1 minus 2u minus u square du. Okay, a typical differential equation of your A level maths. This is your dx over x. Okay, so now from now on it is your A level mathematics. So we have to integrate both of these sides. Okay, you see that I can spot here that the derivative of this denominator is minus 2u. Okay, so I'll be multiplying and dividing with minus 2. So this is minus 2u over 1 minus 2u minus u square du. Okay, I'll just keep it this right now. Okay, so this is going to be, let me change the colors so that the steps remain clear to you. Now this is going to be minus half ln. This is 1 minus 2u minus u square. This is your ln x. And I can write here ln c. Okay, so we have minus half ln 1 minus 2u minus u square, that is equal to ln cx. Okay, and I move this 2 onto this, एक step खा लेते हैं. Okay, so this 2 goes over here. It first of all it comes here. Okay, and then this shifts onto here. Okay, so now this is going to be ln of 1 over 1 minus 2u. I'm just going to take care of this minus, so I'm going to write its that reciprocal, minus u square. That is going to be ln c square and x square. Okay, so we have reached the level where we can put the things back. Okay, so this is going to be 1 over 1 minus 2u minus u square, and that is equal to c square x square. Okay, is it clear up to this? Yes or no?
Yes, sir.
Okay, when we go beyond this, is going to be 1 equal to c square x square. Okay, and all of this will be cross multiplied here. So I'll be writing this back into its original form. That will give me 1 minus 2y over x minus y square over x square. Okay, I can take x square, the LCM over here, and that x square will be cancelled with this x square. So we have c square into x square minus 2xy and then minus y square. Okay, now again you have to be very good at your algebra, but so I am going to make some space to show you how we'll be completing the square over here. Okay, so let me take this y square plus 2xy. Okay, so I need an x square to complete this square, so I'll be writing minus x square with that. Okay, so this will be y plus x whole square, and then I have minus x square. And since there was a minus over here, look at these minuses. Okay, so this will be minus and this will be plus over here. Okay, so this is 1 over c square is going to be this is going to be x square minus y plus x whole square, and then plus x square. We can change this 1 over c square with k square or a square, whatever. Like this is still a constant. So I'll be writing this as k square, okay? So this is 2x square minus y plus x square. So this y plus x whole square is going to be 2x square minus k, okay? And then we have finally, this is y plus x, and we plus minus the square root of, this is 2x square minus k, and this y is going to be plus minus 2x square minus k minus x. Okay, so that is how,
Yes, sir.
yeah, so this is how we're just beginning to end this differential equation chapter, okay?